In this video, we're going to explore the concept of a two-sample confidence interval for a proportion. I want to give you an overview of this procedure here. So imagine we have a bunch of 6 people, and there's this new drug to treat the symptoms of this particular illness. And so in order for the drug to get approved, it has to go through some kind of a clinical trial. So, well, to simplify things, we'll call it an experiment. So researchers will randomly select people that are sick who volunteer, and will randomly assign them to 2 different groups. Okay, and so the populations, of course, are too big, so we don't have everyone. All we have is volunteers who are selected. So we have to use essentially samples. So we have a treatment group; those are the people getting the drug, and then the control group, people who are not getting the drug. And what we want to do is compare how many people still are ill after some time after taking the drug. We'll say within a couple days or something. So based on those the volunteers who are volunteering for the experiment, we use randomization to either put them in the treatment group or the control group. So P1 here is the proportion of all sick people in the treatment group, right? And then P2 here would be the proportion of sick people in the control group. Okay, so that's we really want to know, right? We want to know these proportions after, say, 1 week after the experiment's taking place. Okay, so then based on these samples, we could estimate the proportion of people who are sick in the treatment group. And so what we would do after some time after taking the drug, we would count the number of people sick in the treatment group, and then basically divide that number by the number of people in the treatment group, and that would give us the sample proportion. Okay, in this case, the sample proportion of people sick in the treatment group after some time. Likewise, in the population 2 or sample 2 in the control group, we calculate p hat 2. Once again, it's based on the number of people sick in the control group divided by the number of people in the control group. Okay, so after some time, say a week of taking the drug, right, the people in the control group don't know they're not getting the treatment, they're getting like a placebo, right? And so after some time, if our drug treatment works, we would expect probably P1 to be, or P1 to be less than P2. That's what we expect, but we don't know those values. So what we do with this procedure is we take a look at the difference of P1 minus P2. Okay, so that's the true difference of the population proportions. We don't know the true value of that, and that's what we're going to estimate. And so we do that using a confidence interval. So as you've been seeing, a confidence interval is a point estimate and adding and subtracting off a margin of error. And there's 3 ways to represent this, right? When we do this, our point estimate is just going to be the difference of sample proportions, right? That's our point estimate, and then we subtract off our error. We take our point estimate and add our error. Okay, and the confidence interval basically gives us the likely possible values that will estimate P1 minus P2, which is the true value. So we use that point estimate and the margin of error, and that will can be expressed also alternatively as the point estimate plus or minus the margin of error, or as a confidence interval that looks like this: left endpoint or lower endpoint, right endpoint or upper endpoint. Okay, so once we do the calculation, we are typically going to run into 3 scenarios. The first scenario is when we get our lower limit and our upper limit, we claim that the difference of 2 proportions falls between those 2 numbers. And the first scenario here is that these values, the interval contains all negative numbers. In other words, 0, the interval is entirely to the left of 0. Okay, so that would tell us that this interval has all negative numbers. So what does that mean? Well, we can state with certainty that P1 minus P2 is less than 0, which means that P1 is less than P2. Meaning, if you go back up to the scenario here, P1 is the proportion of people sick after taking the treatment. So this is good news because that's saying that the treatment we have less what do you call people sick now than the control group. We would expect the control group to be about the same as when we initially started. Okay, and so P1 is less than P2, so that means the drug in this case, the treatment is working. However, sometimes the result may come out to be something like this, where now our interval of values consist of all positive values, and the interval is entirely to the left of 0, which means the interval contains all positive values. So what does this mean? It means that the difference of P1 minus P2 is greater than 0, or P1 is greater than P2, and that would indicate people are actually getting more sick than the control group, and treatment is definitely not working. And the other possibility is if we get a confidence interval that contains the value of 0. So this is probably not good, meaning researcher usually doesn't want to see this because this means nothing. Basically, it's inconclusive because zeros here we have positive and negative values, and so what does that mean? We can't make a definite decision. The difference could be negative, or the difference could be positive, or in fact it could be 0. And so in this case, the researchers are not sure. The experiment is basically inconclusive, and so a lot of money is probably wasted there. So with difference of confidence intervals, you run into these, a difference of parameters or difference of proportions. You're always going to run into these three typical outcomes. And this is for a difference of, say, means as well. And that's the idea when you're asked some of these questions about, can you say one population mean or proportion is bigger than another population mean or proportion? It depends on what type of confidence interval you got. Did you get all negative numbers or positive numbers or a mixture of both? And so that's the idea of how we compare confidence or two population means or two population proportions